Hello, Math Humans. We're going to do 9.1a today. We're going to start our chapter on sequences and series and factorials. Our objectives today are that we're going to use sequence notation. We're going to write terms of a sequence. We're going to use and manage factorials, and then we're going to do some grapher work. So we have a bunch of definitions in the beginning, and I've pre-written them just to help us move through our notes a little bit more quickly. The first one is an infinite sequence. So it's a sequence of terms that continues to infinity. So there's no end to the potential number of terms in the sequence. A finite sequence means that the sequence has a definite beginning and a definite end. Okay? So pretty self-explanatory on those. This is the one thing as we start moving through this little section in pink. The notation when we're talking about sequences and series is super important, and you need to make sure that you understand what all of the variables represent as we are moving through this chapter. Okay? The first thing is n. N is a number's position or a term's position in the sequence. So if I had 3, 7, 9, and those were the terms of my sequence, this would be n is equal to 1, n is equal to 2, and n is equal to 3. So it is the number's position in the sequence. Okay? A sub n then is a specific term in the sequence. So if I use what I have, a sub 1 would be 3, a sub 3 would be 9. So this says this is the first term of the sequence, this is the third term of the sequence. And then I had one written down. If I have a sub 15, that means that is the 15th term of the sequence. A sub 0 and a sub 1, a sequence can start with either, and you need to pay attention, and we'll talk about this as we do some work in our calculator. But a sub 0 is going to be an initial term. And I think about this, so we'll talk about this one, like if I buy a car. And let's say I buy a car that costs $20,000, okay? Then a sub 1 would be my first month's payment, okay? So that's just an example of the difference between a sub 0 and a sub 1. In the sequence that I had right here, I started this sequence with a sub 1, right? There was no initial term. So oftentimes the problem will tell you whether you're starting with an a sub 1 or an a sub 0, okay? A rule, you'll see this word a lot. They will say find a rule. A rule is an equation to generate the individual terms of the sequence. So for example, I might have a sub n is equal to 3n plus 7, and so I would generate all of the terms of the sequence using this. This is actually called an explicit formula. We'll talk about the differences in those in a minute. And then a sub n might be a to the n minus 1 plus 3. This is a recursive formula, and those are going to be other vocabulary words we use as we walk through this chapter. All right, let's start in with our examples. So for example 1, you're going to be given that a sub n is equal to 3n minus 2. That is the rule that will generate the terms of the sequence. And I want to write the first 4 terms of the sequence, okay? And unless you're told to start at a sub 0, we will start with a sub 1. So a sub 0 is often used for an initial, like a purchase or an initial sum of money, but unless you're told otherwise, we're going to start at a sub 1. To generate this by hand, and I want to look and see in my examples when I start using my handy-dandy calculator, and actually I will show you how to do it on this one, okay? So my first term, if I do this by hand, if I use the rule, this is going to be 3 times n, remember that's the number's position in the sequence, minus 2, and I would get 1. A sub 2 would be 3 times 2 minus 2, and I would get 4. A sub 3 would be 3 times 3 minus 2, and I would get 7. And then A sub 4 would be equal to 3 times 4 minus 2, and that would give me 10. So if you're told to do the sequence by hand, then this would be how I would generate those terms. When I report, I would write A 1 to 4 using my subscripts. Because we're talking about sequences and series, we use the goofy looking little brackets, and then I would write those numbers in my sequence and use the curvy little brackets. Okay, and actually I think I'll wait to show you the calculator work for just a bit. Alrighty, the second example is going to say write the first 5 terms of the sequence. Okay, and I will show you the calculator on this one because it will give me an opportunity to show you several skills. So this particular rule is going to have a negative 1 to the n, which means that I'm going to have some sign changes, because if n is positive, then a sub n will be a positive number. If n is negative, then a sub n will be a negative term over 2n plus 1. Okay? So what I'm going to do on this one is I'm going to show you the first couple of terms by hand, and then we're going to use our calculators. So this would be a negative 1 to the first divided by 2 times 1 plus 1, and you would get a negative 1/3. And then the second term would be a negative 1 to the second divided by 2 times 2 plus 1, and I would get 1/5. Okay? If you continue doing that math, you would get that a sub 3 is equal to a negative 1 over 7, a sub 4 is 1/9, and then a sub 5, which you can't see, a sub 5 would equal a negative 1 over 11. I would report a sub 1 through 5 is equal to, and then I would write my negative 1/3, my 1/5, negative 1 over 7, 1 over 9, and a negative 1 over 11. So now what I'm going to do is show you how to do this in your calculator. And it's actually really cool, but it has many steps. So the first thing I'm going to do, let me see if I can zoom in a little bit so you can see my calculator. Come on, zoom in a little bit. It helps when you push the right button. Okay, so the first thing that I'm going to do is I'm going to put my calculator in sequence mode. So I'm going to go here and go to sequence. And then I'm going to quit. And I'm going to go to my y equals. Okay, and you'll notice all kinds of stuff. So when you're using your grapher, and you have your grapher in sequence mode, and you go to your y equals, you're going to get an n min, and then you're going to get a u of n, and then you're going to get a u of n min. And let me explain what each of those lines mean. The first one is, which term are you starting on? The default is 1, so, and that's where we started, so our first n was 1. The second one is the rule, and we had parentheses, a negative 1 raised to the n, okay, and then we're going to divide by, everything has to be in parentheses, 2n plus 1. Notice that when I'm in sequence mode, the variable that my calculator is using is n, because n corresponds to sequence mode, okay? So that's my rule, and then I'm actually going to leave the third term, or sorry, the third line blank, so that your calculator can manage that math itself. We'll talk about later when you need to do that. So then I'm going to quit, okay? And now my u lives up above the 7, so I'm going to do second u, and then I'll move it up so you can see it a little bit, and I'm going to do 1, 5. The comma also lives up above the 7, so it's right here, and I'm going to hit enter, and then I'm going to math bracket. And notice that I get the exact same answers that I did when I did the math by hand. So when we go back and just fill in our notes, this is the term of the sequence that I'm starting on. This is the rule, and this is that first term of the sequence. So I don't always have to put that value in, so most of the time I'm going to choose not to. We'll talk about later when you need to put that value in. And then I do U on my calculator 1, 5, and it will spit out the terms 1 to 5. If I had done 1 to 10, then it would have spit out the first 10 terms. I could do something like U 3, 20, and it would spit out the terms from 3 to 20. So it's actually a really cool tool. My preference for sequences is that you would math frac it if possible, because oftentimes sequences, if we have to write a rule from the numbers, it's easier if those numbers are in fraction form. Not always, but just a suggestion. All right, so let's move on then just to talk about those couple of terms that we talked about before, explicit and recursive. So an explicit formula writes a rule based on the term's position. So that's going to be written in terms of n. Let me zoom out a little bit so you can actually see what I'm writing. Okay. All right. A recursive formula, on the other hand, is written in terms of the previous number, or I'm going to write term, okay? So that would be a sub n minus 1. If a sub n is the current term, a sub n minus 1 is the previous term, okay? And just for posterity, a sub n plus 1 would be the next term. So that's kind of handy to get your vocabulary down. A sub n is the current. A sub n minus 1 is a previous term. And a recursive formula is written in terms of, sorry, there's a lot of T's, the previous term. A sub n plus 1 is the next term. So if I wanted to have a formula for explicit, that might look like a sub n is equal to 2n minus 5. And again, remember that n is the number's position, okay? A recursive formula would be a sub n. The current term is equal to the previous term plus a number, okay? All right, so let's do a couple of examples for this. So for example number 3, I'm going to write an expression for the nth term of the sequence. If you're not told how to write the rule, I would typically use explicit because it's a little bit often easier. That's explicit, okay? So we're going to be given the sequence 1, 3, 5, and 7. So this is my sequence, dot, dot, dot. And then this is n is equal to 1, n is 2, n is 3, and n is 4. So I'm given the first 4 terms of the sequence. So in general, my explicit formula would be a sub n is equal to 2n minus 1. So example, if I multiply n by 2, I get 2. Subtract 1, I get 1. If n is 2, 2 times 2 is 4, minus 1 is 3. If n is 3, 2 times n is 3, minus 1 is 5. We will do a few problems where we try to come up with the sequence. Sometimes they're difficult. The primary focus of PreCalc is being able to use these rules and then do additional math from there. So yes, I understand that this process can be challenging. Some people it's very simple. For some of us it's challenging, but we're going to do our best because that's not going to be the primary focus of our material. Example number 4 says write an expression for the nth term of the sequence. And again, I'm going to do this one with explicit. There's a time and a place for recursive. So this time we're going to be given 2, -5, 10, -17, ... When you see sequences, they will have ... showing that the sequence continues. So if this is n is 1, n is 2, n is 3, n is 4, the first thing to notice is I have alternating signs. So my a sub n, I'm going to have a -1 to the n plus 1. And that's going to manage my alternating signs. And then this one is n squared plus 1. Again, this is sometimes a little bit difficult. This is a hard thing for me to do. I struggle with this. Sometimes I can get there. But again, it's not the primary focus of what we're going to be doing. Okay? The next thing that we want to talk about is factorial notation. And factorials are really cool. Okay? So a factorial is a special type of sequence. And if I have 3 factorial, that means it is 3 times 2 times 1. If I had 5 factorial, it would be 5 times 4 times 3 times 2 times 1. And so it would be all of the previous numbers multiplied together. Okay? If I have n factorial, which I think is really cool, it's going to be the first number, just like this, times n minus 1 times n minus 2 times n minus 3, etc., etc. Okay? And if you look at the example, I often use this if I get, here's the first term, I subtracted 1, I subtracted 2, if I went over here, I subtracted 3, I subtracted 4. So if you have a variable as a factorial, it's also still possible to write that out. Okay? So let's do an example. This is going to be example number 5. And it says, write first 5 terms of the sequence given by a sub n is equal to 2 to the n over n factorial. And I'm actually going to do this one in my calculator. Okay, so I'm going to bring in my handy dandy grapher. It's still in sequence mode, so I'm going to enter the equation that they gave us. So it's 2 raised to the n, and then divided by, and then I'm going to do n. The factorial lives under math, and then probability. And notice that option number 4 is factorial. Okay, so I have 2 to the n divided by n factorial. I'm going to quit. The last time I did the math, I did the first 5 terms, so I'm just going to do second enter. There's the first 5 terms, and when I hit enter, math bracket, and there are the first 5 terms of the sequence. So I would say a sub 1 to 5 is equal to 2, and then 2, and then 4/3, and then 2/3, and then 4 over 15. And then if the numbers seem confusing, it's because we're dividing by a factorial, and so you could do that math by hand, and it's really kind of fun. Alrighty. The last example that I want to show you is just how to use your calculator. So this would be example 6. Using your grapher when it says evaluate, and we're going to do it by hand first. So if I have 8 factorial over 2 factorial times 6 factorial, the numerator would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial, and I'm going to put it here, is 2 times 1. 6 factorial is 6, 5, 4, 3, 2, and 1. Well, notice that all of those numbers cancel, which is really nice. So I just get 8 times 7 divided by 2, and I would get a 28. I will tell you that there are times when you're trying to use your calculator, so I'll do this one in my grapher. So I'll put it here so you can see. So I would do 8 math, and then I go to the left because I think it's a little bit faster, and then divided by parentheses, and I'm going to do 2 math, go to the left, factorial times 6 math, and go back to my factorial, parentheses. So I have 8 factorial divided by 2 factorial times 6 factorial, and then I get an answer. Occasionally with the factorial, you will get an overflow error on your calculator because your calculator gets pissed off. If that's the case, what you need to do is you need to simplify before you start putting numbers in your calculator because it's too many calculations for the calculator to manage. Alrighty, that is it for today. I will see you soon.